right, so like we talked about in class, when when we're finding the area of a curve and that curve happens to be below the x-axis, um, and the x-axis is our boundary, we end up with a negative value. So when we have two curves that meet and part of the curve is above the x-axis and part of the curve is below, we actually have to integrate twice. So we can't use that formula, oops, the wrong color, where we just find the difference between the upper curve and the lower curve if part of the curve, right, is above the x-axis and part of it's below. So we're basically going to find this curve that I'm drawing first above the x-axis. That'll give us a positive area straight out. And then we're going to go ahead and find the curve, the area of this curve below. But what's going to happen initially is we're going to get a negative value because the x-axis has an equation of y equals 0. And when we integrate, this is the upper bound, so we say 0 minus whatever the value is using the integral from negative 3 to 3 of this function. And so we end up with a negative value. So we can't do it all at once because we'd end up with an area that's incorrect. So we have to do it in two pieces. So we're going to do the pink piece first, and then, okay, pretend this is on the line, and then this blue piece. Because the problem says find the area between negative 3 and positive 3, so that means this whole thing. Okay, so, and I went ahead and kind of sketched this out for us with the computer, so we didn't have to do this. But if you didn't know kind of how this graph looked, you could sketch it because you guys know the premise. You know, these are the y-intercepts, quadratic functions, and things like that. So you could do a rough sketch to see how it looks. All right, so let's go ahead and integrate. And I'm going to erase this so I can see my numbers a little better. So I'm going to integrate from negative 3 to 3, and I'm going to do the upper function first. So negative x squared plus 9 dx. So when I integrate this, and I'm going to go through this quickly because you all know how to do this because we've practiced doing this for a few days now. My integral is negative, when I integrate I get negative 1/3 x cubed plus 9x. We're looking at negative 3 to 3 for our domain, or for our boundaries. So all I'm going to do is I'm going to substitute 3 in for x and get, and then I'm going to subtract the lower bound when I substitute negative 3 in. So when I do that, I get a value of 36. Okay. Alright, and we've done that before, so that's why I'm not taking time to go over that now. So now we're going to do the bottom curve. So from negative 3 to 3 again, the difference is we're below the x-axis this time, so you'll see that we're going to end up with a negative value coming out. Okay, so that's where we're integrating. When we integrate, we get 4/3 x cubed minus 36x. And again, we don't need to add k because in this process, k gets wiped out. So I'm going to repeat the same process that I did above where I'm substituting 3 in for every x. So I'm just going to write this out in case you're not sure what I'm talking about. I'm sure you are because we did it in class today. Okay, so there's my substitution of the upper bound minus, and then in parentheses, because I'm subtracting both of these terms out, 4/3 times negative 3 cubed minus 36 times negative 3, and then this is all close. This negative applies to this term and this term. So what ends up happening when I do that is I get a negative value, which is negative 144. Areas can't be negative. Since we're below the curve, we know that it's just because the order in which we are, it's because the boundary is 0 above. So we're just going to take the absolute value of negative 144. Okay, I shouldn't put equal signs. We need to take the absolute value of negative 144, and that gives us positive 144. So we're going to add our two areas together. So the area of this is 144 plus 36, which means the area of this shaded part, I can't get my mouse to work. Okay, this green part, the area within the curve, has an area of 180 units squared. Alright, so that is how you do those problems.